Okay, so this is going to be reducing radicals. So hopefully you've worked with the prime factorization because you're going to be using prime factorization to reduce radicals. Just so you know, the square root sign, that symbol like that, that's called a radical. And the next thing you need to know is that the square root sign and squared, just like this here, are opposites, which means they cancel each other out. So if you were to have the square root of 5 squared, the square root and the squared would cancel each other out, which means that this would just be equal to 5. So now that we know that, let's look at a perfect square. We have the perfect square of 9, which we know is 3, but we could rewrite this as the square root of 3 times 3, which would be equal to the square root of 3 squared. And as we just learned, a square and a square root are opposite, so those would cancel each other out. And so the square root of 9 is equal to 3. So you're going to need to know that when we're moving on to reducing these radicals. So starting out with reducing radicals, we're going to use all the same numbers that we used in our prime factorization video, just to kind of help out. So what we're going to do is when we have the square root of 75, which is not a perfect square, and we want to reduce it in its most reduced form, first we're going to do is we're going to find the prime factorization of 75. So what we're going to do is we know that 75 is 3 times 25, and we know that 3 is prime, so we stop there. 25 is not, so we continue. And we do know that 25 is a perfect square, and it's equal to 5 times 5. So if we were to write this out, then the prime factorization of 75 would be 3 times 5 times 5, which would also be written as 3 times 5 squared. So what happens is, since we know that a square root symbol or a radical and a square cancel each other out, these cancel each other out, which means that the 5 can come out of this radical, but because the 3 did not have a square, it must stay under there. So this reduced radical of the square root of 75, its most reduced form is going to be 5 times the square root of 3, and we can't do anything with that. So let's move on to another example. We're going to do the square root of 92 in its most reduced radical form. So we're going to start by doing the prime factorization. And the prime factorization, let's see. I noted that it's even, so we're going to have 2 times 46. 2 is prime, so we stop that one there. 46, however, is not, so we continue. I know that 46 is even, so I'm going to divide that by 2 as well. So we're going to get 2 times 23. And both of those are prime, so we're stopped there. The prime factorization of 92 is 2 times 2 times 23, which can also be written as 2 squared times 23. So if we were to rewrite this, this would be the square root of 2 squared times 23. And we need to remember that a square and a square root are opposites, which means these cancel out, which means that this 2 can come out of the radical. So this 2 is now there all alone. And this 23, because it was not squared, it was all alone, it cannot come out of the radical, so it stays in there. So the most reduced radical form of the square root of 92 is 2 times the square root of 23. Alrighty, let's move on to another example here. The square root of 48 in its most reduced radical form. So first thing we're going to start is by doing the prime factorization. So I know that 48 is even, so I'm going to do divided by 2, and 2 times 24 is 48. We know that 2 is prime, so we stop there. 24, however, is not, so we're going to continue there. 24 is even again, so we're going to have this 2 times 12. This 2 is prime, so we stop there. However, the 12 is not, so we continue it again. Now we have 12, which is also even, and that's going to be 2 times 6. And the 2 is prime, so we stop there. The 6, however, is not, so we continue on there. And 6 is 2 times 3. And both of those are prime, so we stop with both of those. So when we write out the prime factorization of 48, we get 2 times 2 times 2 times 2, that's 1, 2, 3, 4, 1, 2, 3, 4, times 3. So now, in the prime factorization, we have written this as 2 to the 4th times 3. However, we're only going to group these in groups of 2, so we know what we can take out. So we're actually going to write this as the square root of 2 squared, that's this one right here, times 2 squared, that's that group of 2 there, times 3. Okay, so there's 2 sets of 2 squares and 1 3. So since these are both squared, they get to come out as a 2. This 2 squared right here comes out as this 2 times 2 squared. This comes out as a 2 as well. And then times the square root of 3. 3 does not have a square, so it can't come out. So now we reduce this. We had these two squareds. The squares get canceled, and these 2's came out over here. So now we have 2 times 2 times the square root of 3. 2 times 2 is 4. And then you can't reduce the square root of 3 and 4 and something under. The radical cannot be combined. So the most reduced radical form of the square root of 48 is 4 times the square root of 3. And we'll have other examples like this, so don't worry. Okay, in this case, we're doing the square root of 29. If we do the prime factorization of 29, 29 is already prime, which means it can only be multiplied by 1 in 29, which means nothing can come out of this radical at all. So the most reduced radical form of the square root of 29 is just the square root of 29. Nothing can happen there. And now we have the square root of 36. This one is a perfect square, so hopefully you know that it would just be 6, but we're going to do this through prime factorization just to show you how this is going to work. So we have 36. If I start to factor this, I know that it's even, so we have 2 and 18. 2 is prime, so I stopped there. 18, however, is not, so we're going to continue there. So we have 18, which is also even. That's 2 times 9 is 18. 2 is prime. 9 is not, however, so we continue with the 9. 9 is also a perfect square, and that is 3 times 3. Both these 3's are prime, so we stop there. If we write out the prime factorization of 36, we get 2 times 2 times 3 times 3, which we can rewrite as 2 squared times 3 squared. And so if we put that under this radical over here, we have 2 squared times 3 squared. This square root and that square cancel out, which means we get this 2 out here all alone, and the square root and that square cancel out, which means we get this 3 out here. So now we have 2 times 3, which gets us 6. So the most reduced radical form of the square root of 36 is 6. And then we're going to have a second video that's going to involve some more multiplication and combining on the outside of the radical. So continue on to that video now.